Hello, folks. Welcome. My name is Joe, and I am from Twilio, and I will be your next session today. We're going to talk about everything you need to know about REST APIs. I should have a screen. If Rosendo, if you can throw my screen up, that would be wonderful. Excellent. Hello, I'll be with you for the next 60 minutes or so as we introduce you to the wonderful world of Internet APIs, looking in particular at a thing called REST APIs. If you don't know any of what I've just said means, do not worry, we're going to be diving in from the start and moving all the way through from the barest basics of how does the internet work, how does information get moved around the internet, all the way through to how you can use REST APIs in your own applications and in your hack projects. And why am I talking about these topics? Well, first and foremost, REST APIs are kind of a pivotal skill if you want to work at all in web development, particularly if you want to build applications that use data or services from any of the other data the other services out there. And I work for a company called Twilio, which is well known for producing a REST API that allows you to send and receive phone calls and SMS. And this week we have challenges all throughout the week for you to use the Twilio API to make your phone do fun things powered by your applications. And so rather than do a Twilio workshop, we're going to get into the basics of what is a REST API and how does it work, so you can apply that knowledge and those skills to any API that you may want to use throughout this Global Hack Week, or indeed in your careers or hacking to come. First up, I can drop the link for the GitHub doc. I will be watching the chat. Thank you, Ave, for giving me an opportunity to demonstrate that. I'll be watching the chat. This is going to be interactive. I don't have a presentation or anything for you. I'm just going to do the things, and we're gonna play with REST APIs here live. And so if you have questions or you want to do deep dives in particular topics, we can go off track. That's totally fine. I am here to answer your questions. So do keep it coming in chat. I will be listening and watching. So where do we start? Well, first of all, someone's asked for the link to this GitHub doc. This GitHub doc is the guide for the Twilio Challenges here at Global Hack Week. When you go to the GHW MLH website and you look for your challenges, every day you will find a Twilio challenge there. So for example, today is Ring Ring Hello World, and that challenge will link you to two things. It will link you to the day in the guide, and it will link you to the submission link for the dev post. That day link goes to the GitHub document that I just had open. So we have a guide and a tutorial for every day of Global Hack Week. So you can come to this guide and get all of the steps you need to complete that day's Twilio challenge. If you join in late, so say for example you join in today in day 2, all of these challenges do build on top of one another. So I do recommend, if you're getting started with the Twilio challenges today, that you scroll back up to day 1 and you do day 1 and then move on to day 2, because these challenges build on top of each other. So by the time you get to day 7, you'll have done a whole thing. So with that in mind, let's jump over to Excalidraw and talk about what we're going to be talking about today. So as I mentioned, we are going to be chatting about this little thing called REST APIs, and there are two components to this that we need to talk about. There is the REST part, this first word, and there is the APIs part. And actually, we're going to start with the APIs part. There is also a week-long challenge. Thank you, MLH folks. We have a week-long challenge also detailed in this guide for playing Twilio Quest all week, and you can win a Twilio Quest prize pack for taking part in that, as well as the daily challenges. So yes, we've got two things to talk about today. We've got REST and we've got APIs. And we're going to start by talking about APIs. I imagine by now that a lot of you have heard this term before, but for those of you who haven't, API stands for Application Programming Interface. And that font is altogether too large. Just tune it down a little bit. API stands for Application Programming Interface. Anyone want to have a punt at what that means? Anyone got any ideas on what an application programming interface is and why we might care about it? I see someone saying you're slowly making your way through it. Great. It is intended to be worked through slowly. You do have all 7 days. The way we've built that challenge guide is we've taken the task of getting started with Twilio and we've stretched it over 7 days so that every day is a bite-sized piece, so you don't have to stress too much, because we know there's lots of other things that you want to get done during Global Hack Week, and so we've tried to make those pieces as small as possible, so that you can do just a little bit every day. Hey, Sam says like a waiter at a restaurant. Someone joined us for the last Global Hack Week tutorial, or Operator Academy. One of the two. We've had this metaphor before. Yeah, it's like a waiter at a restaurant. What does that mean? Well, whenever you build a program or you write a library or you use someone else's code in your code, there is a set of things that you will do to make that code usable. So say, for example, you were writing your own JavaScript program to print out the day of the week. Right, so you've just got a little program in whatever language you prefer, and it has a function, and when you call that function, it tells the user the current day of the week. What you've just done there is created a application programming interface by creating a function that, when called, it produces the output of the program. You have given another programmer a way to work with your program. In other words, you have provided another programmer a way to interface with your application. So an API is essentially the any programmatic interface that you expose to allow other people to use your code or to use your service. And these things take up various forms. So one of the forms that I just spoke about was you might have a API for a library. So you might have a library and that exposes an interface to use the functions within the library. So that's one way that you might see an API. So whenever you import some code into your code, and you start using the functions and the classes that you import, what you're doing is you are using an API that another programmer has made available to you. But today we're here in particular to talk about web APIs. So these are APIs which you are accessing over the internet. And you're doing that using web protocols. So what do I mean by a web protocol? Well, that can vary, and this is where we're going to start leaning towards the REST part. But there are many different protocols that power the web, and a protocol is essentially a set of communication rules that enable us to all speak the same language, all use the same applications. When we talk about the internet and we talk about the web, there's actually a lot of different protocols that make the web work. But the main one that we are all exposed to is HTTP. And a lot of you, even if you haven't, thought or done much web programming, you'll probably recognize these initials because they are at the beginning of every address and every URL you type into your browser bar, where we have HTTP or HTTPS. I'm just going to take a break there and check chat. Ika Martin said, I just did a week of API on a bootcamp and used the same metaphor. Perfect. And someone said that's the example in every YouTube tutorial. That's good to know. So let's go back to that example. Why is an API like a waiter at a restaurant? That is usually referring specifically to web APIs, but I mean, I guess the metaphor works for everything else. And basically the idea of an API being like a waiter at a restaurant is you can think of the kitchen of the restaurant as the back end of your application, right? So in the kitchen, the chefs are taking all these ingredients and they're mixing them together and they're doing all this hard work and they are producing complete meals. And you can come into that restaurant, you can sit at your table, you can look at the menu of what's available, and you can communicate that to a waiter and you say, hey waiter, can you go and fetch me this amazing complicated meal? The waiter goes to the kitchen, gets that meal for you, and it arrives at your table. And all of that amazing work of producing that meal has been done in this invisible black box in the kitchen. You don't have to see or interact with it. You don't have to know how that meal is made. You don't have to know any of what the chefs did back there to make that meal possible, because you have the waiter as an interface to work with that kitchen to produce that meal and bring it to you. So that's where the metaphor is. If we talk about importing a library, say we're importing any library in your favorite programming ecosystem, and you grab a library to use the file system, or you grab a library to use your favorite web service, that will provide some functions for you that hide the complexity in the code that you're using, a bit like talking to the waiter, right? Reminds you of Craig Dennis. Hey, Craig Dennis, fellow Twilio on my team. Craig actually has an amazing course at Free Code Camp on the intro to APIs. Also, if you play Twilio Quest with us this week, if you go for the weekly challenge and you play Twilio Quest, you will encounter Craig's API course in the mission called the API Academy. Craig Dennis is a wonderful video teacher, and so if you haven't encountered Craig's API course, jump in the Twilio Quest and play it. So that's why an API is like a waiter. So we've also spoken a little bit about the difference between APIs as a general concept, and more specifically web APIs, and we've just gotten onto this concept of HTTP. So why is HTTP important to web APIs? Well, HTTP, the hypertext transfer protocol, is broadly speaking how the web works. It is how our computers and the services that make up the internet send requests and transfer data to each other. So whenever you use the internet on your computer or on your phone or from a program, what you are actually doing is sending HTTP requests. So let's see an example of that. Let me go over to Google. So I'm in a new tab on my browser, and if I type in google.com and I press enter, what happens here is that my browser sends a HTTP GET request to the google.com server. The google.com server receives that request and says, hey, someone is making a request to get the contents of this website, and it returns the HTML that makes up that page. We can actually see that happening if we went to the inspect. So in your browser, you've got some developer tools that allow you to interact with web pages as a developer. And these have numerous facilities. For example, you can see the HTML and the JavaScript that make up that page, but you can also see all of the network requests. So if I were to give this a refresh, you'll actually see right there at the top, let me zoom that in. You'll see right here at the top that a GET request has been sent. Oh, sorry, let's move that over. Oh no, I can't. There we go. You'll see at the top we've got this GET request. That is the actual request that is sent when we go to this web page and ask for something. So why is it called a GET request? What does that mean? Well, HTTP has a variety of what are called methods or verbs. And these are used to tell, these are used by the client to tell the server what kind of request they are sending. So HTTP is this protocol that we use to send, requests to web services. Let me split that over a couple of lines. There we go. So HTTP is this protocol that we use to send requests to web services, and it is composed of a variety of methods and verbs that allow us to communicate to the server what kind of request we are making. And they're called verbs because they are just usually a series of words that, describe the action you're doing. Why did I used the wrong tool. So in this case, I sent a GET request, and the GET request is really simple. It does what it says in the tin. It is when you are asking for something. So it's when you are sending a request to get some information. So it's very descriptive, very, very obvious right there on the tin what a GET request does. Does anyone know any other types of HTTP request? Anyone encountered any other types of HTTP request in chat? I'll have a drink while chat throws out their favorite HTTP methods. Post. Perfect. Post is the second most common one you're going to encounter, and a post is the opposite of a GET. It is when you send a request that contains some information. So it's when you're sending information to the web service. We also got patch. Patch is another great one. Patch is for updating information on a web service. So patch, make sure I'm not going to lie about this. There's two. There are patch and there's put. And they're very similar. They're for updating information, but one of them allows you to send partial information. One of them you have to send the whole piece of information again. And I can never remember which way around they are. I think patch is partial and put is the total. But yeah, we've got a request for put there as well. So these are some different forms of HTTP requests that you'll send. So when you go to a website in your browser, you are almost always sending a GET request. So here we can see that we've got this GET method that's been sent to this domain, and we can see here that that Google has then transferred some data back to me. So usually when you go to a website with your browser, you're sending a GET request and you're getting back a web page. The information you're getting back is some form of HTML document, JavaScript, CSS, the different things that make up a web page. So you can see the actual GET request here that I sent when I loaded the page, but you also see there's a load of other requests. There's gets and there's posts and there's all kinds of things. And these are because web pages aren't just simple static clumps of data, but they themselves, contain functionality that will load further things. So if you've ever done any HTML, you may have, for example, embedded a CSS style sheet in your HTML using a script tag at the top, or using a script tag at the top. Those tags will actually initiate a request, another HTTP request, to load further information. And so that's what we're seeing here. For example, here we're seeing a GET request that goes and fetches the Google logo. These post requests, which you'll see are blocked, are requests to Google's ad server, sending all of my information to Google, and my ad blocker has blocked them. So you can see all of these different web requests have happened just to load this single page. But that's for a web page from our browser. Our browser is one type of thing that is called a HTTP client, basically. So HTTP has got two sides. You've got HTTP clients and HTTP servers. Your clients send HTTP requests and retrieve data, and HTTP servers receive requests and send data. So our browser is just one example of a HTTP client. We can have lots of other types of HTTP client. For example, my terminal is a HTTP client if I'm using something like curl. So curl is a command line tool for sending HTTP requests, and it allows you to query APIs, or just send HTTP requests, any HTTP requests really, to kind of anything you want. But it's especially useful for interacting with web APIs. So one of the APIs that is really easy to get started with is the GitHub API. So I could do something like sending a request to api.github.com to the user's endpoint and then we can get Joe Nash. There we go, perfect. That hesitation was me not completely remembering if I remembered the URL. But here, so I'm using curl to send a GET request to the GitHub API, and I'm going to the collection of all the users on that service, and then I'm going to query my GitHub profile. And you'll see what this has returned. So this is a HTTP GET request, just like the one we sent in our browser, except this hasn't returned a web page because I'm in the terminal and I'm querying an API. It wouldn't make sense for me to get some HTML back here. What we've got here is a different data format called Json, which is formerly the JavaScript object notation, but is kind of abstract from JavaScript mostly. It is just one of the many formats that is popular to send information around on the internet. And in this case, the information that you get in JSON will be key value pairs. So we've got a property and a value. So here I can see the login name for this user is Joe Nash. The ID for this user is 1790822. And that contains all of the publicly available information from this API. And I've been able to do that with curl. You can grab curl. Curl is a really popular and widely available command line tool. You can grab curl. Zavosta also says wget is also another very similar tool. There are different in a subtle way. Wget is primarily used to actually download files from the internet. So it is making HTTP requests, but it's primarily geared towards actually downloading information, whereas curl is for it's kind of like a HTTP, it does all kinds of protocols, WebSockets a lot. As you can see here, it supports basically every internet protocol you can imagine. And they're subtly different. If you wanted to download an entire website, for example, and build a web scraper, you might use wget, whereas if you wanted to experiment with an API, you might use curl. Really great little tool, and you will see more of curl in the weekly Twilio Challenges. So the reason I wanted to show you curl is just as an example of when we talking about HTTP client, we can mean lots of different things. We can mean our web browser, we can mean our terminal using a tool like curl, or if you are building an application and you write a HTTP request in your code, your program, your application is then a HTTP client. Great question from Lovely Bubbles. Just adding the name of the site is automatically a get because you didn't send the get verb. That is correct. So in curl, if you don't specify the HTTP method, it sends a get request. You can specify the method with the X flag. So the X flag means like what HTTP method you're going to send. So if I were to do -x get and then do that same API, you'll see the exact same thing happens. But I can also change that to get, to post, to delete, all those kind of things. I won't because you can't post to that endpoint, that API endpoint, and posting all of the APIs that use post on the GitHub API require authentication. So I won't do that as an example. But yeah, you specify the method with -x, but by default it defaults to get because usually people most often want to get. So that is a little introduction to HTTP methods. Let's talk about the server side and what happens over there. So I've just shown you sending some requests around in different ways. When we were in the network inspector for the Google site, there was also another piece of interesting information on here, which was the status. So when we send a request from a client to a server, the server receives that request. It has to do something with it, right? It wants to use that request to either send you back some data or to initiate some kind of action. And you're going to want to know, as the person who sent that request, as the application that sent that request, what exactly has happened, what the server has done with it. And this is where status codes come in. So there's a lot of status codes. They range between 100 to 500, and every group of 100 is kind of a grouping of different meanings. So actually the best way I'm going to show you this is on the MDN website, because that has a really nice little web page breaking out all the different groups of codes. So a server will respond with a number between 100 and 500, 100 and 600, and they're bracketed into groups of 100. So 100 to 199 is informational responses, 200 to 299 is success messages, different types of success messages, 300 to 399 is redirection, and I'll explain what that means in a moment. 400 to 499 is client errors. So that means you as the client sending the HTTP request have done something wrong. And 500 to 599 is arguably the most important, which is server error responses, which means that something has gone wrong on the server in fulfilling your request. So the most common, what you always hope to see, is 200. That is 200 okay. That is just generic success, and it means your request has been received successfully. Here we're acknowledging it, letting you know that everything is fine. Here is your data. The other one that you'll probably really commonly see is 400. So for example, if I were to just go to like, I don't know, let's go to twilio.com, made up URL. I should hopefully get a big 404 not found. 404 not found is one that I'm sure you've all seen at some point or other, and that means the page doesn't exist or the page is not found. And this is a 400 error. That means it's a client error because you as the client going to the wrong web page or sending a request for a resource that doesn't exist is considered your bad, not the server's bad. It is not the website's fault that you tried to get something that doesn't exist, so it's considered a client error. Yes, exactly. 404 not found is actually your error, which kind of makes sense, right? Clearly you want to see a 418. Is 418 I'm a teapot? 418 is I'm a teapot, right? Yes, I'm a teapot. Okay. There is a lot of weird jokes built into the very infrastructure that powers the world. If that's a scary thing to have found out, I'm very sorry. One of them is HTTP 418 I'm a teapot, and this is an old April Fool's joke where there are internet connected devices. You're probably increasingly aware of things like Ring doorbells and smart cameras and all kinds of things on your network that may be an internet connected device. And there is, in the early days of this happening, there was this joke that like if you send a HTTP request to an internet connected coffee machine, that's not going to do anything because it's a coffee machine, it's not a web server. And so 418 I'm a teapot exists, whereas you're bad because you've sent a request to a teapot, but it's just telling you I can't fulfill your request. I'm a teapot. So there are all kinds of like weird jokes built into PHP. Is a language full of these Easter eggs. But when you kind of go back to anything that touches like the early days of the internet, you find these weird April Fool jokes and Easter eggs. And 418 I'm a teapot is one of them. Joe Fro says, so a 400 to 499, it means clients making invalid requests. Yes. But however, there is a kind of catch to that, which is that that's what the standard says. So the HTTP requests 400 to 499 is the intention for that is to say it's a client error, but sometimes we use unexpected response codes. We use response codes incorrectly for other reasons. So a really good example of this is like security by obscurity. So say for example, we went to not Jonathan Arms. So for example, we went to my GitHub profile, right? So this is my GitHub profile, and say we went to my repositories and we looked for a private repository that I own. There we go. What's on this one? There we go. We'll go to my Tiddly wiki. So we look for a private repository that I own, right? So this is on my profile and it is private, which means I can see it because I'm logged into GitHub, but you can't. If I were to go to a tab that's not logged into my GitHub and I go to this URL, what you'll see is a 404. Now that is somewhat counterintuitive because what it should actually be is like an authorization issue, right? So if we were to go to redirection, oh, sorry. Yeah, we go. It should be a 403 forbidden, right? So we've got 404 not found when really it should be a 403 forbidden, which means I'm unauthorized or I don't have access, or there's also 401 unauthorized. It should be one of the many messages that indicates I don't have access. Why is it a 404? Well, in a security context, sometimes you actually don't want to reveal that something exists. So if I had gotten a 401 or a 403, something which indicates that I don't have access to this resource, someone then knows that this does in fact actually exist. So TiddlyWiki exists and is private, but like again, made up repo is also a 404, even though this one actually doesn't exist, whereas TiddlyWiki does. But GitHub is choosing to return 404 to not expose the information that that this resource exists and you don't have access to it. So this is I think this is interesting because this is a great example of this is the standard. This is what these requests are defined as being for. But as with any specification, any standard, people will deviate from that. And sometimes it's for a really good reason. In this case, it's kind of a security thing. Other times it's because they haven't understood the standard or they're not following it. But this is just a general warning to whenever you're using an API or you're interacting with a web service or you're writing your own web service and you're interpreting these rules, be aware of, the fact that not everything follows the rules perfectly and some people forge their own path, if that makes sense. So that's the status codes. So HTTP, we have status codes, and status codes indicate indicate how the server has handled your request or not handled your request, as the case may be. Let me zoom out a bit. Cool. So we've now spoken about HTTP and we've spoken about the methods. Yes, those Mozilla docs about the status codes are awesome. In general, the MDN web docs are a really high quality place to get documentation about about anything to do with web development. This is kind of my default go-to. I'd highly recommend it. Really, really great resources. So we spoke about HTTP, how it works, how you send requests. Hey Ashwin. Why are we talking about that? Well, I said that we'd get to the REST part. So let's get to the REST part. Let me actually abbreviate that. So REST means, or REST stands for hello. Let's move that up. REST stands for Representational State Transfer. Where's the... I don't know where the E is, but yeah, REST stands for Representational State Transfer. And it is a set of best practices for creating HTTP APIs. And I'm saying that very carefully because you'll hear the word REST API a lot, and you'll hear about REST APIs a lot. But that term is, as many words do, has a long and complicated past. So the idea for REST APIs initially came about from like an academic thesis, and then has evolved and became kind of this industry pattern for creating REST APIs. But what the thesis sets out and what the reality has become in the industry is not necessarily the same. And I want to tell you this because you will, if you were to just Google REST APIs, you might see some really complicated, really in-depth information that makes it seem very complex and scary. But the reality of what most services and most people think of when they think of REST APIs is actually not that complicated. So we're going to dive into what a REST API is, and we're going to do that based on the stuff we've learned so far about HTTP and requests. So let's go back to the GitHub API, and let's have a look at this curl request. So this curl request that we were using earlier, let's zoom in on that a bit. Okay, so let's talk about this URL and the structure of this URL. So, and I'm going to make this clear, this is a GET request. Okay, so when we talk about sending a GET request to https api.github.com/users/Joe Nash, when we start to talk about REST, the form of this URL and the method that we're using for any given URL becomes important. And we want to think about things in terms of resources and the and collections, essentially. So api.github.com is just where the API lives. The significant part here is users. So in REST, in a REST API, we want to talk in terms of resources and collections. So in this case, users is a collection of all of the user objects that live within this database, that live within this API. And we then want to pair those resources, those URLs, with the methods that make sense. Wilfred's dropping some great analogies. What REST allows us to do is have a consistent interface, a consistent way of navigating URLs with HTTP. So when we see something like users, that is a collection of user data. That is a collection of every user that exists on GitHub. If I was a HTTP client and I was coming to the GitHub API, what HTTP methods does it make sense for me to use with users, right? So I've got an API that exposes all of the GitHub users. Well, the only thing it really makes sense for me to do is to get that information, right? Like, I'm a random user. I shouldn't be able to, delete that information. I shouldn't be able to create new users through the API. That doesn't make sense for a user to do. So it only really makes sense for me to get that information. So from this URL, I should expect that if I see a collection, in the URL, that's going to be for a get method. And indeed it is. If I were to get that, I would then get all of the users in a paginated fashion. So hitting a get request list gives me all of the users. And it's the same if I were to go deeper. So if I were then to go Joe Nash, and I would send a get to this, again, this is the same. So this is a individual resource. So the resource for Joe Nash in the users collection, and just sending a get request to that just returns the info. Now, if I were to have something like /users/create/Joe Nash, so this is an endpoint that says you can send a GET request to users to the create endpoint, and you're going to call that thing you're creating Joe Nash. This is a valid way of writing an API. This is a thing you can do. You can go and create a web service that has an endpoint for creating things, and the next, the next part of the URL is the name of that thing you want to create. But this isn't RESTful, because REST wants you to use the HTTP methods kind of semantically, right? It wants you to like the HTTP method dictates what you're doing. So we will never see like here we've got creation, that's sending data to this service. That's not what a GET request is for. A GET request is for retrieving data, whereas creating should be a post. So that was, let's go to the whiteboard and break that down a little bit more. Okay, so let's take a step back and talk about REST APIs. So we have a URL, and say, for example, we're going to go with the GitHub URL, the GitHub API. Right, so we've got this users, and users is a collection. Users is all of the users on GitHub. And if we want to get user data, we send a HTTP request to that API. And that makes sense, right? You want to get data, you send it to that API. If we wanted to create a user, we would use a post request because we're creating data. So we would, to create a user, we would post. And when we post data to a API, that URL in a RESTful situation, the URL should not change to indicate that the action we're doing is creation. So what I mean by that is that in a RESTful API, the action that you as the client is doing is defined by the HTTP method and not by the URL structure. So does that make sense, chat? How are we feeling? Let's get a vibe check from chat. Because I've recognized that what I started out doing here is kind of a comparison between how you'd write a REST API to a non-REST API, and that may not make sense. This is your first API you're seeing. Great question, Rodian Man. So Rodian Man says, can we go against REST and update the data in a GET call? Yes, you absolutely can. So REST is just one way of writing APIs. REST is a pattern that developers follow because it produces consistent and nice interfaces. It is not an immutable law of the internet. You can write your APIs however you want. So that example I said earlier, like, if you were going to write, if you were going to make like, let's say you were going to make a web service that's like my cool users API. You could totally have, you could get a user with HTTPS mycoolusersapi.com users, you could get a user that way. You could then have them create a user with HTTP mycoolusersapi.com create user. You can totally do that. There's nothing to stop you. There's nothing to stop you doing this, but this is not RESTful. What would be RESTful is sending a post to this. Because with a GET request, we are expecting to receive data. With a post, we are sending data. And so in a RESTful API, we want the HTTP method to guide what we're doing. And creating a user is the server receiving data from us, and so it should be post. And so we let the data guide us. So the data that we're using, or the data we're interacting with, is the user's data. So it's going to be on the user's endpoint, and then we are creating, and so it's post. Whereas if it's the user's endpoint and we are getting, it is receiving that data. Does that make sense? So while there's nothing stopping you from doing that, it is not technically RESTful. But as we kind of spoke about with the HTTP status codes, whether you follow a set of rules or not, a set of best practices, is really up to you, and there are valid reasons for not following it. REST is a very popular pattern because it makes things really easy to understand for everyone, and it kind of gives a consistent interface. So, if I were to go to a random API on the internet, for example, let's go to the Pokemon API. Here you go, here's the Pokemon API. So if I go to the Pokemon API, this is a RESTful API. And I go to, actually, let me do this in curl. Well, actually, you can see it right here. So if I grab pokeapi.com API v2. So if I were to do curl x get hps pokeapi.co API v2 Pokemon. Perfect. Yeah. So if I were to do a GET request to this API, this is the same pattern as that GitHub API, right? So we've got the API itself, and then here's the collection of all the Pokemon. And I know that I can go to, Bulbasaur, and I can throw a GET request at Bulbasaur, and I know what I'm going to get. Why is this the same pattern? Well, let's grab this and throw it into our whiteboard and talk about that. So if we have the GitHub URL and the Pokemon URL, okay. So what we are seeing here is we've got the URL for the service itself, and that's not important. So that's actually, how do I format text? Okay, I don't know how to actually cross text that. Can I do that? Can I do that? No, I cannot. Okay, so we've got the URL for the API itself, and that's not important. What's important is these slashes after. So the users Joe Nash and the Pokemon Bulbasaur. Because what this is saying is, like, this is a collection of data, this is a collection of data, and this is an individual item in that data, and this is an individual item in that data. And so I know, because these are both RESTful APIs, that if I send a GET request to /Pokemon, I'm going to get all the Pokemon. If I send a GET request to /users, I'm going to get all the users. If there's then a particular user that I want to get, I can go one step further and get that user. If there's a particular Pokemon I want to get, I can go one step further and get that Bulbasaur. It's like how on your desktop computer, all of the applications, the exit window, the buttons to exit are all up here. They all have a file menu. There's a consistent interface. Following REST best practices is the equivalent of that for knowing how to send HTTP requests. If you have an API that is following RESTful best practices, you know that if you want to get some data, that you find what the data is called and you send a GET request to it. If you want to create some data, you find where the data is and you send a POST request. So that's why REST exists as a standard. It's not it's not a set of laws. It's not the way things have to be, but it is a choice that we make as developers to make our APIs easier to use. Does that make sense? Squadron said, "Hey Joe, what is your typing speed?" This comes up every Global Hack Week and is not actually that fast. It's like 90 or something. I type very fast, but I'm very inaccurate is the problem. I make a lot of mistakes. The reason it sounds very fast is because I have a very loud keyboard. So if you ever want to seem like you're a really fast typer, just get a really loud keyboard. Okay, so that's the basic gist of the whole REST thing. The main thing that you need to use as an API creator, as an API consumer, is that you want to pair the appropriate HTTP verb with the action that you're taking. And when we're talking about creating applications, you will most frequently hear of Crud. You've probably heard this. Ooh, sorry, I got to make a new. Where is my undo on Scala draw? You will probably have heard of Crud. So let's go over here. So Crud is like a kind of like a really common way that kind of applications are built, and this means create, read, update, delete. And whenever you create a new application, if that application has a database or it has some data that it's working with, a lot of what you'll be doing on that application is creating, reading, updating, and deleting data. And so REST gives us a way to take these actions and attach them to meaningful URLs. So again, let's take our hypothetical Michael users database example. So this say Michael users database is an API for building users and storing them in a database. So if we were going to create a user, we would do something like send a post to /users. If we were going to read a user, that might be get to /users. If we were going to update a user, that would be a put to /users. And then if we were going to delete a user, that would be a delete to /users. And notice how the URL here doesn't change. We're not doing /users /create, /users /update, /users /delete. We're letting the HTTP method tell the server what we're doing with that request. Alrighty. So we've got about 9 minutes left. Great question, Squadron. Great question. So we've got 9 minutes left. Plenty of time for questions. Feel free to ask any questions. Otherwise, I'll go into some ways you can practice this week and some places you can get some more information. But to answer Squadron's question, when there is web APIs, why does RESTful APIs come into pictures in the first place? Well, a REST API is just a kind of web API. So a web API is just any API exposed over a web protocol, right? So an API is just the set of instructions you use to interact with a program. And a web API is any API exposed over a web protocol. HTTP is a web protocol. So you have HTTP, this idea of having requests, HTTP requests and HTTP responses. And so that allows us to structure our APIs. And then REST is REST uses HTTP. Actually, let's say REST sets some best practices for HTTP APIs. So when it comes to a REST API is just a web API, but the main difference is like it's an evolution on those ideas. So when we say we've got a web API, we're like, hey, we've got an API, some functionality that's exposed over the internet via HTTP. REST gives us some best practices for deciding how to make best use of those things. It gives us best practices for deciding like, hey, how do I use HTTP to help me structure my API so that anyone who comes into my API immediately knows how to use it without having to specifically, learn about my API. Really interesting question. Can you make money by making REST APIs? REST APIs are one of the dominant forms of developer tools, I guess is fair to say. So lots of developer tools will work by exposing an API. A prime example is Twilio itself. So Twilio, the company for which I work, big public company, provides a series of APIs for developers to use to do things like sending SMS messages or making phone calls. And this business is built on REST APIs. The product that this business sells is access to these REST APIs. And that is basically it. There's a Developers, lots of companies that hire developers are building products for people or for other businesses. And because we can't all reinvent the wheel, we want to build on top of existing tools and existing utilities. And there is businesses to be made by providing those tools and utilities, right? So like Stripe is another example of a business that exists via providing an API to other developers. So yes, lots of the big tech companies you've heard of make their money via making REST APIs. That is definitely a thing. All right, into the Twilio Challenges. So why am I talking about REST APIs? As I said at the beginning, Twilio is a REST API, and so if you want to continue learning if you want to continue learning about REST APIs and you want to practice what you've learned about REST APIs, you can dive into the Twilio Challenges, and there's two things here that I want you to think about. So first of all, the weekly challenge. So the weekly challenge is to play Twilio Quest. Twilio Quest is our free game that helps you learn to code. You can download Twilio Quest for your Windows, Linux, Mac OS, or Raspberry Pi, and this is a fun, gamified way to learn about coding concepts. One of the missions in Twilio Quest is the API Academy, and the API Academy will walk through a lot of the concepts that I've spoken about today, but gives extra videos, extra resources, and gives some challenges so you can reinforce that learning. So if you want to continue learning about REST APIs, or you want to, you forget anything I've said today and you want to brush up on it, jump into Twilio Quest and jump into the API Academy, and there's a great set of resources there for you. Secondly, and also, if you do the Twilio Quest Weekly Challenge, as you complete Twilio Quest missions, you earn XP. The top 5 XP earners by the end of the week will win a special prize. Secondly, as I said, we have daily challenges. Here at Global Hack Week, you'll be completing some challenges every day. These daily challenges will walk you through using the Twilio API, and you'll be doing that via using curl, via sending HTTP requests, and eventually by creating your own Node or Python app. So all the things I've spoken about today, we've spoken theoretically, we've spoken at a high level using this whiteboard, we've sent a couple of curl requests, but we haven't gotten, like down and dirty and practical and, built an application that uses an API. The Twilio Quest challenges are a step-by-step, day-by-day, to teach you from zero how to use the Twilio API, which is just one example of a REST API. And as we said, once you know how to use one REST API, you kind of know how to use them all, because that's the whole point. So if you want to continue learning how to use APIs, follow the daily challenges. It will walk you through, using common tools like curl, really popular, really important tool. It'll get you doing cool things with Twilio, making phone calls and sending SMS messages from your programs. And eventually you'll use frameworks like Express or Flask to build your own application server that receives, that is a HTTP client, HTTP server instead of HTTP client. So I hope that makes sense. I do technically have 3 more minutes. If anyone has a last question they want to sneak in before the bell, now is your chance. Other important thing to mention, in the Great Global Hack Week Discord, there is a Twilio channel. I will be hanging out in there all week. If you have questions about the Twilio challenges or Twilio Quest, feel free to drop in there. If you have questions about anything else that I can help with, also feel free to drop in there. I am just around to help. I will only be reading that channel just because there's too much going on in the other channels, but it doesn't mean that channel has to be about Twilio. Feel free to ask any other questions that you might have. Wilfred says, can I make an API for providing MLHSM resources? That would be awesome. That would be very cool. That would be really fun. Econ Martin, great question. How do you save and exit in Twilio Quest? It's automatic. You don't have to save. Every time you complete an objective, your progress is saved, so you can quit out fearlessly. When you restart Twilio Quest, it won't put you in the same location you were in. You have to walk back to that location, but any objectives you've completed, anything like that, that stays cleared. So your progress is automatically saved. You will have to walk back to where you were, but all of your objectives will remain completed. And then Zenab says, please bring back autopilot. Unfortunately, I have absolutely no power there. I will let that request be known. But unfortunately, I have no control over what happens in autopilot land. How to see the leaderboard? You can see the leaderboard in. I've updated the link in the GitHub document. So in the GitHub document, there is a link. Where is it? There it is. There's the leaderboard. So here's the link to the leaderboard. The leaderboard right now is anonymous, so you'll see that no players have names. I will de-anonymize it probably on Wednesday. We tend to leave it anonymous for the first couple of days, just to keep up the suspense about who's in the lead. I will de-anonymize it on Wednesday, but that is where the leaderboard is. You're already at 45,000 XP, which is an enormous amount of XP. Congratulations, everyone. And by the end of the week, I'll de-anonymize it. The way the winners get announced, keep an eye on the Twilio channel. At the end of the week, I will announce the top 5 usernames, and then you'll have to DM me, and I'll get some information from you to confirm that is your account, and then we'll get the prizes sent out. Squadron, if you want to get in touch with me, the Twilio channel in the MLH Discord is the place to start. Question from Gfro: if you make a GET request for a website server that doesn't exist, what actually sends an error status code back to you? Oh, great question. That's actually fascinating. So if I were to do my made up website.com, definitely made up, what this error, this is not a HTTP error. As Gfro says, this doesn't exist. What is happening here? I'm not getting like a 404 or a 500. This is actually, if you look at the network tab and I refresh this, you actually see that like there is no status code. This is just my browser saying like, hey, that website doesn't exist. We can't find that URL. So this isn't actually a HTTP response with a status code. This is the application saying, hey, we can't find that. No server has responded. Here is an error. And if I were to do that in curl, we'd get a similar situation. So we then get could not resolve host. So that means it can't find a server with that URL. So it's the application that is unable to make that request in that case. Sorry, loads of questions coming in the last minute. I don't have permission to chat. Oh, yep, cool. MLH got that. Are Twilio sponsoring weekend hackathons this season? We are actually a MLH partner. So every MLH member event automatically gets a Twilio prize and Twilio swag from us. So if any hackers at your event are able to enter the most creative use of Twilio challenge, and the lovely MLH coaches will have some so we'll have some Twilio swag with them at the event as well. Okay, alrighty. Any further questions? I'll see you in the Discord channel. Thank you all so much for listening to me ramble about APIs today. If you have any further questions or thoughts or you need resources, please do not hesitate to ask. And I look forward to hacking with you throughout the week. Have a wonderful Global Hack Week.